Hey everybody, welcome to the last video of the week, and I want to talk to you about graphing and describing transformations. I had mentioned what a transformation was in the last video, but we're going to start to go into a little more detail, and then as we move on into other sections of the textbook beyond section 1.1, we'll go into even greater detail of transformations. So if you remember what I talked about in the last video, I talked about the idea that a transformation is just moving one of your parent functions around, and that's the simplest way I can describe it. You take a parent function like f of x equals the absolute value of x, and you change its size. You can change its size, which means you can stretch it, you can shrink it, you can make it skinnier, make it wider. You can change its shape. Okay, that's kind of along the same lines. The absolute value graph would still have the V, but it might be a skinnier V, it might be a wider V, that type of thing, size and shape. And you can also change its position. So you can move it up, down, left, and right. You can also change what's called the orientation. Instead of the absolute value graph opening upward, it would open downward. Okay, and so we're going to talk about how to do those things. Okay, and how do we do those things? We do those things through three different types of transformations: translations, reflections, and vertical stretches and shrinks. So let's define each of those to begin with. Okay, translation's the easy one. Okay, translations shift the parent function horizontally or vertically. Okay. 2 L's, horizontally or vertically. And I'm going to put some things down. I don't know if we get to it in this section or not, but some key things to kind of think about. And so I'm just going to put this in the back of your head, and I'll talk about what it means briefly. First thing, outside of the parent function. Okay? If you are doing something outside the parent function, adding or subtracting outside the parent function, what that's going to do is that's going to be a vertical shift. And I will describe that in example 1, and we'll define that a little bit. And the next thing I want to put in here, if it is inside the parent function, that's going to be a horizontal shift. I'm not sure if we'll look at that today, but I just kind of want to put that in your head, and as we move forward, we'll get into the details of that. Okay, so basically, translation moves it up, down, left, and right, horizontally, vertically. A reflection. Think about a reflection in the mirror. When you're looking at yourself in the mirror, it's just basically everything's the same. It's just everything's flipped around. Okay, a mirror image. So a reflection, it flips the graph over a line of reflection. Okay. And we'll show you an example of that also. Vertical stretch or shrink. Think about some of the graphs we saw. There was the absolute value graph in the last video that was narrower. Okay. Basically, what they did is, if you think of it this way, if they took the absolute value graph and they took a piece of paper and they pulled the top and bottom of it, what would happen to that graph? It would shrink. So they stretched it. Okay, or it would get narrower, I should say. So that's stretching it out. Okay. So basically the idea behind a vertical stretch or shrink is you multiply the parent function by the same factor. parent function by a factor, we'll say that. Okay. Now, if your factor is greater than 1, what's going to happen is you're going to stretch it. So you're going to grab the top and bottom of the paper and pull, and what's going to happen when you stretch something out? It's going to look longer, it's also going to look narrower. If your factor is between 0 and 1, you're going to shrink. Okay? So basically you're going to grab the top and bottom of the paper and you're going to squeeze it together. And what happens when you squeeze things together? It gets kind of a little plumper and a little shorter. Okay. All right, so that's the basic idea behind it. So let's take a minute and just look at the next few pages of examples. We'll try to go quickly through these. Remember, the whole idea is you just kind of want to get an idea of what a transformation is. Okay. All right, so here's what we want to do. On this graph, we want to first graph the function and its parent function, then describe the transformation. And I'm going to do it on Desmos and then copy this stuff over. So if I look at this first graph here, f of x equals x minus 7, hopefully you'll be able to identify that the parent function is f of x equals x, which we know is the linear function right there. So let's look at what happens between the two. So I've got this one. Here's my f of x equals x, 45-degree angle through everything 1, 1, 2, 2, 3, 3. And here's x minus 7. Notice what happens. Whoopsie. Notice what happens. It shifts. Let's get that reset here. It shifts 7 units down. Look at that point right there as compared to that point right there. Okay? It goes down 7 units. Okay? Notice that my parent function is f of x equals x, and then outside of my parent function, so there's my parent function, and then outside of it, okay, separate, I've got the minus 7, and it's a vertical shift. That goes back to what I had mentioned on the previous page. Okay? Outside the parent function, vertical shift. So if you add or subtract something kind of out to the side, off to the side, that's going to go up or down. Okay, all right, so let's graph these two things real quick. So we got our first one that goes at a 45-degree angle. That's f of x equals x. And then we go down 2, 4, 6. Ooh, that's going to be fun to draw. And not perfect, but you get the idea. Okay. Now let's describe it. We talked about describing it yesterday. First of all, what's happening? We'll get a little more formal. Okay. First of all, we have a translation. It's moving, so we're going to say a vertical translation. 4 units down. Of the parent linear function. Okay? Parent linear function. Let's talk about the domain. Okay? Hopefully we can look at that and say all real numbers. And same thing for the range, all real numbers. Domain, it goes left and right forever. Range, it goes up and down forever. All right, next one. First of all, parent function. Hopefully we notice that this is the constant function. So f of x equals 1. Constant. So here's my parent function. Ooh, it's got to go right in the middle there. And then I got to go up 9, 2, 4, 6, 8, right there. Okay. What happens once again? what do we have? We have a vertical translation. Whoops, that should be -9. Back up here. Let's move that down to -9. So it should actually look like that. My apologies. So vertical translation. Now how far did it go? Started at 1, went down to -9. Let's see, let's say 10 units down, because it moved 10. Of the parent constant function. All right, my domain goes left and right forever. My range, remember these ones always have y equals whatever that number is, -9. All right, let's look at the next three. All right, what's our parent function? Half of x equals the absolute value of x. Let's take a look at what these two graphs look like. Well, let me hide that and hide that. There's the absolute value of x. X plus 1. Check that out. Goes up 1 unit. Let me show you something else while I'm here. Notice that's on outside and it goes +1. What if I put the +1 on the inside? Notice I put a +1 on the inside and it moved it to the left 1. And notice if I do a -1, it moves it to the right. We'll talk about that more in class. Okay, but let's just focus on what they have for us here, +1. So you can see kind of the same thing, vertical translation, 1 unit up. So, all right, so as far as notes, I think we can skip that one because it's basically the same thing. Okay, so we'll cross that out. All right, let's look at this one, -x squared. This is so we know our parent function is that right there, x squared. Let's see what that looks like. All right, there's x squared. We get that shape right there. -x squared. Boom, flips it over. Makes everything negative. Notice how in the definition we said we have a line of reflection. It's this line in this case right here, the x-axis. Because that's basically your mirror right there. All right, so how will we describe that? So let's graph it first. I'm going to just draw on a rough sketch like that. Obviously not perfect. And then we'll do that one back there, kind of like that. And what do we have here? This is a case where we have reflection. And what are we reflecting? Of quadratic function. Okay. And what are we reflecting it over? Over the x-axis. Okay, so that's the idea of reflections. Key thing, usually the negative does something to reflect it. All right, last one. Let's look at 1/8 x squared. So there's our parent function. There is our 1/8 x squared. Now notice what happens here. Okay, it looks like it gets stretched out horizontally, but that's not really what we want to say. Basically what we did is we took this graph right here and we squished it. Okay, take the top of it, take the bottom of it, squeeze, and watch it squish. What happens as it squishes? This piece comes out to here, this piece comes out to here. Now in math terms we can't say squish. We have to say shrink. Okay, or stretch. If I were to put one in here that was skinnier than this one, we would say stretch. So we got to use proper mathematical terms here. All right, so first of all, what's our parent function? f of x equals x squared. And we call this, it's a vertical shrink of the quadratic function. Okay. All right, for tomorrow when you come into class, I'll have a couple more examples to show you, and then a modeling example, and then we'll